investigating speed using ballistic pendulum. You have heard the names of simple pendulum, compound pendulum, and here the term ballistic is used. Okay, motion under gravity. For the motion under gravity, the term ballistic is used. So here we are not going to study simple pendulum or compound pendulum. Here we are going to study the experimental procedure to determine the speed of a projectile. Okay. Say for example, the motion of bullet also can be considered as a projectile motion. Say we want to determine the speed of a bullet after it is shot. Okay. So how to determine the speed of the bullet experimentally? That can be done using ballistic pendulum. So ballistic pendulum looks like a simple pendulum or compound pendulum. You know the difference between simple pendulum and compound pendulum. If the mass of the spring is negligibly small as compared to the mass of the bob, in that case that can be considered as simple pendulum. One more condition is there, and that condition is amplitude of oscillation must be less than or equal to 4 degrees. Okay. In these two cases, the pendulum can be considered as simple pendulum. Though we are not going to use any formula related to either simple pendulum or compound pendulum for this experiment. Here, the two principles of physics will be used to determine the speed of the bullet. Here, bullet is the projectile. What happens when the bob of the pendulum is its equilibrium position? That bob is here called target. When the bullet is shot, the bullet becomes embedded to the target or the bob of the pendulum. And then what will happen? Then there will be swing of the bob or the target like this. Okay, there will be swing. So when it is swinging, when it is oscillating, that means it is there is a rise of the height of the target. With this target, the bullet is embedded. Here the collision is assumed to be elastic in nature. And two basic principles of physics are used. One is conservation of linear momentum and another one is conservation of energy. Okay, using these two principles, the velocity of the bullet is determined, right? Just before striking the target by the bullet, okay, what is the kinetic energy of the bullet? It is equal to half into m into v square. V is the velocity of the bullet. Okay, m is the mass of the bullet. So that is the kinetic energy, and at the equilibrium position of the target or the bob of the pendulum, let us assume it to be 0. Okay, and according to the rise, vertical height, okay, that is the rise. Here it is when the ballistic pendulum is in motion, it is going both in the horizontal direction as well as in the vertical direction. And our requirement is to calculate the vertical direction because we are going to calculate gain in potential energy by the combined mass. Here combined mass means mass of the bullet as well as the mass of the target or the mass of the bob, right? So that is the combined mass. So mgh, say m is the combined mass, capital M. Okay. Small g is acceleration due to gravity and h is the rise in height. Right? So that is the potential energy gained by the combined mass and that gain is due to the loss in kinetic energy by the bullet, which is equal to half mv square. So just equate these two things. Half mv square is equal to, here in the left hand side write a small m for mass of the bullet, and in the right hand side you write capital M for the combined mass. Okay, half mv square is equal to capital mgh. So everything is known here. H can be measured experimentally. Small g is acceleration due to gravity, which is equal to 9.8 meter per second square. Masses are known. Mass of the bullet and mass of the target is known. So you can easily calculate velocity. This is the velocity of the bullet just before striking the target. Okay. So this way easily we can determine the velocity of the projectile or the bullet. So this was just a discussion about the experimental procedure of determining the speed of a projectile by using ballistic pendulum. Right? This setup you can find in schools or colleges, engineering colleges, or in the Department of Physics. But nowadays, this technique is not used to determine the velocity of projectile. Advanced technologies are there. But there is a historical importance of such a simple setup, for which these setups are still used in some institutions. Okay. So, one more thing, in this calculation, there are some losses, frictional losses are there. Then air is surrounded. Okay, means I want to say that the bullet or the target is surrounded by air. We are neglecting the effect of presence of air. Frictional effects are also neglected. The collision is assumed to be elastic in nature. Yes, there is some loss of energy as loss of heat, okay, and loss of energy due to deformation, means strain energy, okay. When the bullet is striking the target, there is some deformation of the target as well as of the bullet itself. So since deformation is there, so there is some gain in the strain energy of the bullet as well as of the target. So that strain energy plus some heat energy, if you do your experiment carefully, then you will observe that there is a rise in temperature of the bullet as well as of the target. Okay, that means there is some gain in heat energy. Where from this energy came? All the source of this energy is the kinetic energy of the bullet itself. So not the total kinetic energy, some part of the kinetic energy was converted into heat energy as well as strain energy. And the rest was used to raise the target, means combined mass, target as well as the bullet, to a certain height. So here, for simple calculations, for simple experimental procedures, here the loss due to heat, loss due to strain energy, or loss due to deformation, these are neglected. Okay. So if you neglect all these things, then your calculation will be very easy. Anyway, so this is the end of this lecture. Thank you. Thank you for watching this video.